Hello there. In this video, we're going to talk about writing quadratic functions in factored form. Now, there are really three ways to write a quadratic function. There's vertex form, which we've been talking about. You have your a value, which you find that's half of the second change. And then you have x minus h squared plus k. And this form, either if you look at the equation, it gives you the vertex by picking out the opposite of h and then k. Or you can use the vertex to write the function in this form. So this either gives or uses the vertex. That's when vertex form is helpful. So we've already talked about that one. The next one is factored form. And just like vertex form gives us or it uses the vertex to write it, factored form either gives us or uses the solutions. That says uses. And the solutions are here and here. Notice that just like with the x-coordinate of the vertex, there was a minus before it, minus h, which means it's going to always look like the opposite of what it actually is. The same with both of the solutions. There's a minus before each of them, which is going to make it so that the solutions also are going to look like the opposite in the equation of what they actually are. So today, we're going to start talking about factored form. Next week, we're going to talk about standard form. So for right now, we're just going to kind of skip over that one. So let's look at this function. The first thing we're going to do is we're going to identify what the solutions are. Now remember that the solutions always happen at the x-intercepts, and the x-intercepts always happen when y is 0. We talked about that a couple videos ago, which means the solutions in this function are here and here. Because in both of these cases, y is 0. So these are the two places when y is 0, which means the function is at the x-axis. So the x-intercepts are -3 and -1. So those are the two solutions. Notice also that factored form has an a in it, which means we need to find half of the second change. So I'm going to find the second change. So from 3 to 0, it goes down 3. From 0 to -1, it goes down 1. From -1 back up to 0, it's going up 1. From 0 to 3, it's going up 3. And from 3 to 8, it goes up 5. Now that's my first change. My second change is the change of these. So from -3 up to -1 is +2. From -1 to +1 is +2. From 1 to 3 is +2, and from 3 to 5 is +2. So that means that my second change is 2. My a is half of that, so that means my a value is 1. So if I wanted to write this equation in factored form, I would write f of x equals your a value, which is 1, and then a parenthesis, x, and then this minus s sub 1. The s sub 1 means that's just like the first solution. It doesn't matter which one you pick, just one of them. And then over here where it says s sub 2, that's the other solution. So my two solutions are at -3 and -1, so I'm going to say +3 because it's opposite of, and then x plus 1. So that's a way to write this function in factored form. Notice that we also have the vertex. We have a symmetric lowest point in this function. -1 is the lowest number, and it's symmetric on both sides of it. We have that sandwich that we talked about, 0, -1, 0. So because we also have the vertex, if we wanted to, we could also write this function in vertex form. So you have a is 1, x, opposite of the x-coordinate of the vertex, so +2 squared, and then your y-coordinate of the vertex is -1, so -1. These two equations are the same. If you multiply this out and you multiply that out, no matter what, you're going to end up with the same equation. If you graphed these two, you'd get the same graph. These two equations are equivalent. Even though they look different, that's okay. In future videos, we're going to talk about how you can get from one equation to the other, like what you can do to maneuver it and mix it around to make one look like the other. But for right now, just know that these are two different equal ways to write this function. And if you want to use the solutions to do it, you would use factored form. If you want to use the vertex to do it, you would use vertex form. Now notice down here, there actually is no vertex in this table. If you connect to the symmetric points here, the 0 to the 0, the -2 to the -2, there is nothing in the middle there. There is no vertex. There is no lowest point. These two are tied for the lowest point. The vertex is going to be somewhere in the middle of them. We don't know what the vertex is. So in this situation, we cannot use vertex form because we don't have a vertex. We have to use factored form because we do have the two solutions when y is 0. So the first thing we need to do is we need to find the second change though. So from 0 down to -2, it goes down 2. From -2 to -2, there's a change of 0. From -2 up to 0, it's a +2. And from 0 to 4, it goes up 4. Here we have from -2 to 0 goes up 2, 0 to 2 is up 2, 2 to 4 is up 2. That tells us that our a value is 1, half of the second change. Now I write my function. I have an a value of 1. And then my first solution that I'm going to talk about is -2, so I'm going to say x plus 2. And then my other solution is a +1, so I'm going to say x minus 1. And so that is this function written in factored form. This one we had to write in factored form because we didn't have the vertex. So factored form was our only option here. Now let's try this one. This one we do have the two solutions, so we can use factored form. We also have the vertex, okay, because there's just that one point in the middle of our rainbow, at the center of the rainbow there, if I draw a little rainbow to connect to the symmetric points. I have this -1 sandwiched in the middle of it all. So I could also use vertex form, but in this video, I'm just going to use factored form, even though I could use either. So first for factored form, I need to find the a value again. So from 3 to 0, it goes down 3. From 0 to -1, it goes down 1. From -1 to 0, it goes up 1. And from 0 to 3, it goes up 3. From -3 to -1, it goes up 2. From -1 to +1, it goes up 2. And from 1 to 3, it goes up 2. So that means our a value is 1. So my function would be 1. And then my first solution is a +4, so I'm going to say x minus 4. My other solution is a +6, so I'm going to say x minus 6. And that is this function in factored form. Remember, we also could have written it in vertex form if we wanted because we do have the vertex right here. But since this video is about factored form, I'm just going to write it in factored form. Also remember that whenever the a value is 1, you don't need to write the 1. You could just say f of x equals x minus 4 times x minus 6. You can just leave the 1 out if the a value is 1 because multiplying by something by 1 just doesn't change it. So that is how you write functions in factored form. I hope this video was helpful. Go ahead and start the practice and see how you do.